still in section 1, chapter 2, the last lesson of chapter 2, which would be lesson 7. Quick review. We established 3 methods for determining the inverse of a function: reverse the coordinates, reflect over the y equals x line, interchange x and y, and solve for y. That's your 3 methods for establishing inverse points or inverse graphs or inverse equation. Okay. Remember, domain of the inverse is the range of the original. Range of the inverse is the domain of the original. The inverse of a function may or may not be a function. It's kind of key points from our discussion yesterday. Okay. So inverse of a relation. Some relations are functions, some are not. The inverse relation, which is not a function, can also be determined by the above methods when appropriate. So this is where we're going to kind of talk about that little last piece of your guys' quiz yesterday. Kind of hinted at this, and I kind of challenged you to figure out what it's talking about in terms of making it a function, making it not. We're going to expand upon that today. So they do kind of go into circle land here. They give you an equation of a circle. We don't do a ton of circles in here, even though they are kind of neat to do in terms of algebra. But consider a relation of x minus 3 squared plus y squared equals 9, whose graph's a circle with a center at 3, 0. So that means you have a center of the circles at 3, 0. So you just put a dot here, 3, 0. Okay. The radius is 3. So if you know the radius is 3 of the circle, you know all directions, it's going to go 3, 3, 3, and then 3. And so then you have a circle here. Okay? That's not a very good one, but that's okay. Okay, so describe how to use the graph of the relation and draw a graph of the inverse of the relation. So how do we do an inverse graph of that? So what do we do to do an inverse of a function? Flip the points, good. But then for the equation, we flip the x and the y, right? So it changed to this. And so how this affects it is because for circles, just so you know, they do tell you this. Yeah, it's right here. For circles, they're in the form of x squared plus y squared equals r squared. Now, if it's just x squared and y squared, that means it's at the origin. And so we move this circle right 3 from x because of that minus 3. Just like with parabolas, right? If you have a parabola that's x minus 3, it means your parabola moved right 3. Okay? Well, for this part, if we flip these, y minus 3, it's squared now. So which way does that go? Up. Yeah, up. Good. So it goes up to 3. So the center now is here. Now let's see. Why does that make sense? What was the center coordinate before? 3, 0. What is it now? 0, 3. Just flipped. So 2 reasons. When you look at this equation, this means up 3, opposite of down because it's squared. Okay, up 3. And then also, the center was 3, 0, so the new center of the inverse is going to be 0, 3. 2 reasons. Okay? And so I'm going to go ahead and actually go to a different color for the inverse. All right, so then it says sketch the graphs of the relation and its inverse on the grid. So then now we're just going to take some points here. So I'm going to go ahead and take this point here. This is 3, 3. 3, 3 flipped is? Cool. Stays. Okay, this is 6, 0, so I'm going to 0, 6. We got that point. 0, 0 stays. And then down here we have 3, negative 3, so I'm going negative 3, 3. Do you see my new circle? Right there is your inverse circle. And then the really cool thing, maybe just for me, because I'm the math nerd, is you draw your y equals x line. It is right between the two. Obviously, my black line's. Thank you. My black line isn't very good. My circle's a little oblong here. Like not really good. But oh well. Okay. Describe how you use the equation relation to determine the equation of the inverse. Okay, by flipping x and y. Kind of did all this stuff now. Okay. Determine the equation of the inverse. We already did this. At the top there. Like that. That's your equation of the inverse. And in this case, since it's y, we didn't have to get y by itself, but I think they're going to ask us to do that still here. Okay, we're going to lose my picture here, so hopefully have yours good. Okay. All right. So E, write the equation of the inverse, solve for y, and verifying the sketch in your graph calculator. So we're going to solve for y, and it's going to show you it's the same thing. So if we solve for y, we had y minus 3 squared plus x squared equals 9. So we're solving for y here. So we're going to minus the x squared we're going to square root since we square root it's plus or minus, and we're going to add 3. So the equation, whoops, I want to put the 3 first, my preference. You can put the 3 at the end, but. So if you want to go ahead and try this, dang it, I wrote it backwards again. 9 minus x squared. Okay, 9 minus x squared. If you want to try this, you can put this in your calculator as 2 functions. Put it as 3 plus 9 minus x squared, 3 minus 9 minus x squared. Okay, I will pause the video so you can do that, so you can see it's going to form that circle of our inverse. But I'll pause and let you guys try that. No, you cannot take. Okay, so once you put that in, you're going to see you're going to get your inverse circle. It does form the circle. So the plus piece of the radical forms the top half, and the minus piece forms the bottom half. Okay, it does make sense on restrictions because, just so we remember, what's the biggest thing x can be? Plus or minus 3. Because plus or minus 3 squared is 9. 9 minus 9 is 0. If I put a 4 in here, I get a negative. That's not defined. So that's why there's no values at x equals 4 or x equals negative 4. Okay? So that's just showing you kind of the domain there affects your graph. That's why your graph is an in-between graph. Okay? So using interval notation, say domain and range, so I just kind of talked about this, of the function. Does this agree with your second and third bullets? So, oh, were we supposed to do domain and range of the original? I might have forgot that. Okay, so let's do the inverse first, and then we'll do the original. So what is the domain of this guy that we just did here? Yeah, so let's do the domain. We just talked about this, was x is between -3 and 3. Okay, the range is what? Zero and 6. So our original, so this is the inverse, put a little inverse here. Our original was what? Domain was the range. Oh, cool. Ooh. Breakthrough. You guys flustered me, you're so excited. Okay, and then the domain is from the range. Oh, dang. That is bad news bears. Okay. If you read books to your kids, it says bad news bears, Bernstein bears. Come on. Oh, it's just kind of part of the story of it. Now I'm all messed up. Y-E-R. Okay. X 0, 6, XER. All right, got that cleaned up. Thank you. Make sure your x and y's are correct. Okay. And that is something you can use as simple, like there could be some ugly domain and ranges you may have, and then ask for the inverse. Don't worry about finding it. Just flip it. Okay. Use that to your advantage later. All right, using function notation to write inverse. So if a function f of x has an inverse, so it's important to understand, see how it says if the function has an inverse? So it has to be a function to use this. So we want to make sure we don't write it in the false notation. But this right here, f to the -1 signifies inverse function. F to the -1 stands for inverse function. Okay? If the inverse of is not a function, then we cannot use that notation. That's what I just told you. Okay. So steps. So step 1, replace f of x by y, interchange x and y, solve for y, change y back to f of -1. And that's just the idea that your y is the inverse function. Okay. This is important here because people often think this because they're good with their exponents. F to the -1 is not the reciprocal. It is not 1 over f of x. That is not true. Okay, that's a different thing. That's a reciprocal function. Reciprocal function is different to the inverse function. Any questions on that? What's that? Yeah. Reciprocal is part of rational functions. It goes later with radicals. Yes. We have radical and rational functions as a chapter.
If it was like 10 to the power negative 2, would it be 2
Say it one more time.
If it was 10 to the power negative 2, would it
Mhm.
be 2
So 10 to the negative 2, they're just showing you why not. This is true. 10 to the negative 1 is 1 over 10. So 10 to the negative 2 in math is 1 over 100. 1 over 10 squared. That is true. For this notation, in which kind of Jaden's leading to, yeah, unfortunately, this is not that within what they're talking about. They've kind of stolen f to the negative 1, called it inverse, but does not mean push down. You can't push it down. Does that make sense? Well, it's inverse is not reciprocal is the point. So we know what to do. You flop x and y. I'm just saying, so what they're telling you guys is this. They're saying if they say find the inverse, you don't just say, oh, it's 1 over 2x minus 3 and be done. That's what they're saying. Don't do that. Okay? So they're saying we still need to go y, interchange, solve for y. That's what we need to do. So we're going to add 3, divide 2. Y equals 1/2 x plus 3 over 2. That's your inverse. Now, we can write this as, is that a function? 1/2 x plus 3 over 2 is a function. It's a line. So we can write it as the f negative 1. Okay? F negative 1x. F's the negative 1 of x, 1/2 x plus 3 halves. Just the same thing, but just with the f negative 1. Okay. This one, same steps. Now, kind of you're going to find out what degrees are going to cause issues for inverses being a function. What's your educated guess? Huh? Not greater than 1. Nope, no, not odd, actually. Evens. Evens are a problem because evens are reflective. So like parabolas do this. So if I do an inverse of parabola, I turn it, it's going to be like this. That's a problem. But if a cubic, this guy, it looks like this. It's continuously going up and from, like it's going down to up. So if I turn this, it's going to be okay. It's not going to overlap itself because it doesn't have the symmetry. All evens have symmetry. We'll talk about that more when we do our polynomial graphing. But the point is the evens are the problem. Power of 4 is a W. So power of 4 goes like this. And we'll do those too. Yeah. They just have another turn. A polynomial? So the definition of polynomial is anything that's like a monomial, binomial, trinomial. Like all these are polynomials here. Yeah. So it's a generalized term. Yeah. Okay. All right. So let me erase that there, but thanks for listening. That'll help you for later. Okay. So x cubed plus 4. So we're going to flop. The reason I was saying that is because this right here, x cubed plus 4, will be a function. So we're flopping now. So it's going to be x equals y cubed plus 4. So y. Then we're going to go minus the 4. And we're going to cube root. Do I have to write plus or minus? No, exactly. That's the point. It's odd. Odds can be positive or negative. That's okay. Okay. So that is your inverse. Is this a function? It is. So right. It's one or the other, not both. Exactly. Because cube roots can cube root, like when you square something, it could have been negative or positive and get the same thing. A cube, it won't. If you cube a negative, it's negative. If you cube a positive, it's positive, so it holds its true sign. There's not two sides of the coin on this case, okay? Good question. And so that's all. We're done with that. That is a function. If you put this into your calculator, it will be a function that doesn't fold on itself. Right. If it was x to the fourth, exactly. When you fourth through, you'd write plus or minus, and now you're in trouble because that's going to have a top half and a bottom half like our circle did. Yeah. Very good. Yep. Great questions. Anything else? All right. Okay. Ran over. Okay, so f of x squared minus 4, so you can already see you're going to have an issue here with their inverse not being a function. It's an even, so you kind of have that in your head. So it says graph on the grid to provide this and state the domain and range of it. So we're just going to graph this simple parabola. So x squared minus 4, they did change the scale on us, so I'm going to pay attention this time. So it's right there, it's minus 4. Okay, it goes through here, and onward and upward like that. That's what your x squared minus 4 looks like. So I guess we're staying in blue for a little bit. Domain is all reals. The range is greater, y is greater than or equal to negative 4, not 2. Still mess up on a scale. Really don't like that. Okay, y is greater than or equal to negative 4 is your range for YER. Okay. Now this is another way they write inverse. So if you ever see f of y, that means inverse as well. It's another way they slide in of asking for inverse. And they write it like that. Because yours is being, they've just flopped it, right? They flopped your x and your y. So we're going to say x equals y squared minus 4. Add 4. And I square root of that's plus or minus. So y equals plus or minus x plus 4 because it's an even. Okay, and so what this looks like, this one looks like this. That's the inverse. Okay. And the inverse is domain and range. We can just cheat, yeah? It's this flipped. So my domain here, domain would be x greater than or equal to negative 4. XER. My range is y is all reals. Yeah, because to do the function, we flip the x and y, so the domain and range flipped with it. Okay. And then we'll do, while we have the picture up here, is the inverse a function? No, then Lanley, you want to press everybody because you got the right thing yesterday? How can I make the inverse a function by cutting off the original? Okay, so here's the main thing, and they go over this in the diploma. They hit this quite a bit for some reason. Understanding how to make the original inverse a function. The biggest point is this. Your issue happens when it turns the corner. When it folds right there, that's where the issue is created in making it not a function for the inverse. So to what Langley said, that means that if I want to make the inverse a function, I only want greater than 0 or less than 0. Because then that would just give me the top half or the bottom half. I can't have both. So the vertex, in that case, is very important. I call it the bend. So as soon as you turn the corner, you've now gone into a non-function situation for your inverse. Okay? So both answers are acceptable. These would be the two things you would cut off the original to make the inverse a function. Yes?
Why do we care if the inverse is a function or not?
Well, it's understanding what makes it not a function. Yeah. So why do we care? Because we want to know what's causing to not be. Yes.
That's how you would answer that question.
Right. X greater than 0 or x less than or equal to 0. We'll do a couple diploma questions to even make it a little bit weirder. Well, I'll show you what they did.
Why do they want to do that to us?
I know, they do.
Why do they do it?
They just, yeah, it's tough. So like, for example, if I said your domain was x less than or equal to 4 and x less than or equal to negative 4, just between these two, which part of those would have would be a function for the inverse. So x less than or equal to 4, right? Here's 4. If I go less than, am I going around the turn?
Yeah.
That's not a function. Less than or equal to negative 4. Am I ever going to have a turn? That's a function.
So can we start anywhere?
Yeah.
We're going to the very best.
Right.
So we can start it at like 10 if we want to.
And 10 and go to the right.
Yeah.
Yep.
How do you know it's going to bend like that, though? Just kind of getting a number.
Well, remember, I'm taking the x value, and if it says less than, I'm taking less than, means I go left.
Oh,
I went around the corner. As soon as you go around the corner, you're now no longer a function.
how do you know that it just keeps going straight down?
What goes straight down?
Like the.
Because when I'm saying x less than or equal to negative 4, I'm talking about what this graph original is doing for after 4.
Oh, okay.
So I'm following that graph left. Does that make sense?
Yeah.
I see what you're saying, but I'm staying on the graph as the answer. Okay, all right, just some food for thought. Okay, all right, we got that. All right, so Don incorrectly determined the inverse of the function defined by y equals x minus 3 to be the equation of x squared plus 3. This is also one they like try to trick you with. He graphed the inverse of function, obtained a parabola. So this was his graph. He did the inverse. He got x squared plus 3. So explain why Don's equation, the inverse, is not complete, and why the graph, the correct inverse, is not a parabola. So if we go ahead, you're going to be confused, because if we go ahead and do this real quick, which we can do. Okay, oh, I'm in highlighter. Okay, x equals y minus 3, square both sides, add 3. We do get y equals x squared plus 3. So before we talk about why this is not true, let's talk about what's the domain of this is the original. What's the domain? Yep. Remember, can't have a negative in the radical, so it has to be 3 or higher. Okay? And then what's the range of the original? A radical graph, he forgot, goes like this.
What is it going like? Oh, yeah.
Greater than or equal to 0. Okay? So there's not a plus minus because they gave us this as the original. That's a you're making a good connection. Okay? So what Janet says, she said, well, does this have a plus minus on it? It doesn't. That's the problem. That's the problem. Because if I told you to find the inverse of this, we would get what? A plus minus. And so we only have the top half. We only have the top half. So the problem is this has to be restricted to these two. Because the domain and range just what? Flips. So my inverse will be, domain will be greater than or equal to 0.
So if the original said y is equal to plus minus square root of x minus 3,
Then we'd be good. If it said plus or minus, then you would say, yep, we have a full parabola. Right, so if this said plus or minus, what that would look like, it would do this. Be this, and be this. We'd have both sides. And so your range would be all reals, not greater than or equal to 0. Oh, the opposite directions?
Yeah.
Not doing that. No, we're not doing that. That only happens when it's a square inside. Yeah, that's only for squares on the inside. Right, that's the circles. Yeah.
So that's the rainbow thing.
Right.
Whatever.
Okay, and then this right here would be y greater than or equal to 3. So the point is, using our knowledge that the domain and range just flip is really important here. Because if you take the domain and range of this and flip it, it shows you what the problem is. Okay, so x squared plus 3 we're still going to use, but what part of it? Only the part bigger than 0. Just this piece. You only draw half of it parabola. That's all. And then if you look, this right here, x minus 3 is this. Again, there's a reflection.
That's x minus 3?
That's the radical x minus 3, yes.
So just in like the
Correct. So since it's not have a plus or minus, it's essentially only half the parabola. So you draw your parabola, but only half of it. Makes sense, but not really, right? All right, so got a couple more things here. All right, determined. So now to composition, f of negative 1 of x and f negative 1 of f of x of 2x minus 3. It's all right. We'll cheat a little bit here. We'll write what we got there. So it's not that big of a deal. They're just showing you that what happens. So we have 2x minus 3, and then our f of negative 1 of x was, add the 3, divide the 2, so it was it was x over 3, like 1/3 x, 3 over 2. Is that right? Yeah. Can you just write what? 1/2 x? You can't write x. 1/2 x plus 3 over 2? Oh, the whole thing? Sure. Yeah, that's fine. Yeah. So if you want to write like this, that's fine. A little hard to see the slope there, but if that's fine, that's fine. So what they're saying is they want you to, essentially composition, they want you to put this in this x, and then put this in that x and see what happens. So that's what composition is, right? So they'll do the first one. Put the inverse into f. So we're doing this one first. Okay, see that? And then we have a minus 3 here. So I inserted the inverse into my x of f. So I have 2x minus 3. And we're just going to simplify it. Yeah, it takes practice. 2 times 1/2, that cancels. It's just an x. 2 times 3/2, it cancels a 2. It's just a 3. 3 minus 3 is gone. You're left with x. Yeah, and we're going to do the reverse right now. And if I do f of negative 1 of f of x, so I'm putting this 2x minus 3 into that x now. So I'm going to go 1/2 2x minus 3 plus 3 over 2. What did I lose you? Oh, this pulled it from we did that earlier. Yeah, that's just the inverse of this. Yeah. Okay, and so if I simplify this now, 1/2 of 2 is just x. 1/2 of 3 is 3/2. Negative 3/2 plus 3/2, we get x again. So that's not a coincidence. Two functions f and g are inverse of each other if the other ones are composite. Sorry. Start over. Two functions f and g are inverse of each other if f of g of x equals x or g of f of x equals x. So if you want to test if things are inverses, you can put them in for each other and see if it comes out to be x. All right? Right. If you want to test it to be an inverse.